Thank you for joining us. I'm Brian DeLuca along with Nicoletta Mino, and we'll be your host for today's live chat, real-time monitoring and control with Arduino, sponsored by Mouser Electronics and Arduino. We have some great panelists in this live chat, so make sure to ask your questions in the Q&A at the bottom of your screen. Now to Nicolette.
Thanks, Brian. I'm Nicolette, and today we are joined by Jesse Masters, Manager of Solutions Architecture at Arduino, and Robbie Might, Solutions Architect at Arduino, to talk about real-time monitoring and control with the Arduino Opta and the I/O expansion modules. So today we're going to learn how these technologies enhance precision in industrial settings and more specifically in water level sensing. So thank you, Jesse. Thank you, Robbie, for joining us today. We do appreciate your time. So
Great to be here.
Yeah.
Great to be here too. Thank you guys for the invitation and the panel.
Absolutely. But before we get into the specifics, why don't we do a brief overview for those of us who are joining who aren't, that well versed in the Pro? Jesse, do you want to kick us off and tell us about the Arduino Pro? What is it? How it works?
Yeah, absolutely. So I can imagine most people have heard of Arduino before and have likely used Arduino in any of their hobbyists or educational efforts, especially as an electrical engineer. Almost everyone has used an Arduino at some point in their lives. Arduino Pro is a new business unit separate from the Maker and EDU business units of Arduino, and is focused on the enterprise market. We have a number of products spanning system on modules, as well as smart sensing, and even some turnkey finished devices like the Opta today. So Arduino Pro is really focused towards the enterprise market, serving it with high-grade industrial-ready MCUs, SOMs, and finished products. Robbie and I make up a part of the team, the technical support team that serves customers across the US and globally with the extended reach of our team. So that's really what Arduino Pro is about. Same company, same idea in terms of the open source, easy to use, easy to deploy, but with a enterprise sort of coat on it that makes it perfect for keeping that the identity, the core identity of Arduino's easy to use platform, but ready to use in an industrial case.
So how is Arduino Pro addressing the industrial use cases?
That's a really good question. So as I said before, we have leveraging the same tool chain and tools that everyone knows. We've developed a number of different solutions, and today what we're really talking about is this Opta here. So this Opta is a micro PLC form factor, but it really does have one of the Arduino SOMs, the 410 to H7, sort of baked into this. So it really brings let's say a microcontroller focus into the industrial use case segment where the ease of use has really been underserved. And so we think this is a really, really interesting play into the industrial automation space. The price point is one of the most attractive things about it. PLCs can cost $800 to $1,000 for a single one, and then you pay for, let's say, the software on top of that. The Arduino Opta is available on the Mouser site for between $150 and $200, and that makes it a really compelling use case for peripheral use cases in industrial automation. Again, you can program it in you can program it with Arduino C++, as you've known in the Arduino IDE, or you could program it with industry standard IEC 61131 languages such as ladder logic, structured text, and we'll show a really cool example of a water automation use case here in a second. But returning back to, again, the place that Arduino has to play in industrial automation, it's really about unlocking simple, easy to implement use cases with something like the Arduino Opta and the family of expansion modules that come along with it. So being able to cost effectively insert 8 analog inputs that can also be programmed as digital inputs, 4 relay switch outputs, Ethernet with Modbus TCP, field bus with RS-485, Wi-Fi, Bluetooth. It's a really compelling small form factor with a lot of compute on the inside. Any other anything you want to add, Robbie? Anything that I missed there?
No, I just feel a little bit of I mean, yeah, I mean, all what you said, it nailed very well, but you know, it's just amazing how we are really coming into the hands of the user, the people who are actually like, whenever I was a teenager, or you know, still trying to get into the field, you know, using an Arduino now, that it's an opportunity to have a device that is industrial, that actually can work with it. So that's kind of like the takeaway of just adding what you said.
Absolutely. And one more really important part of industrial grade, as what we see at Arduino Pro, is security. So being able to not only collect the data easily, but get it securely to a cloud is really important. And not only do the system on modules and all of the microcontroller sort of products we have include a secure element, because that SOM is built inside of here. There is a secure element, a cryptographic chip that's tamper-proof, that this is the thing that enables you to securely connect this device to AWS, to Azure, or even Arduino Cloud, our own cloud offering. So there's a lot of easy ways to get data to the cloud using Opta, which is a really big part of the IoT story with Arduino.
Right. So you
That's
mentioned
what I was going to ask.
Yeah.
Actually, I was going to ask you if you can connect it to the cloud, and which clouds.
Yeah.
Right. And also,
yeah,
I mean, you mentioned some of those, right? But what about cloud security?
Yeah, I mean, it's really good. It's a really good point. And I think I think Jesse just mentioned the secure element. So that is very important, because that secure element that Arduino has in their products, they can actually create TLS connection, but connecting to MQTT and secure the flowing of the data one by one. So that's the requirement that AWS, Azure has in their core for us to do cryptography. So we can get inside of our secure elements, or store private key,
Right.
and private key, and we also public and private key, so we actually can sign in certificates and things like that with the authority, right? So it is very important to mention that, because that's also the way that our devices get certified in those platforms. So it's just a really compelling history that we have worked with them, and we have AWS as our partner. So just give you that. Anything else to add to that, Jesse?
No, I think that was really great. I mean, the final piece with that, I think that's really valuable is again, having enablement and like tutorials, like how do I actually connect this to the cloud? And we have published tutorials on connecting to AWS, as well as if you use Arduino Cloud, it's actually like a click-through wizard that can take about 10 minutes to simply provision a device online. We know that provisioning is a really, really important story when it comes to enterprise, because you're typically trying to deploy thousands or hundreds of devices, and you know, if it takes 10 minutes to do each one, that can really, really add up. So ease of use is really top of mind across all of Arduino Pro.
Now you mentioned obviously the Arduino Cloud, right? You mentioned AWS. Did you mention something else in there too, or did I miss it? I felt like you mentioned
Azure.
It was Azure as well.
Azure.
Yeah,
okay.
we have
so there
Azure.
we go. Nicolette's
Yeah,
showing it for us. Nicolette's showing it for us on screen. So there you go.
No, it's okay. We do have a library with Azure. So by the way, that we have there. So, and we have the tutorial. So it's for free to the users to go there and double click on those. But yeah, so that's kind of like what we have. Of course, Arduino Cloud, which it runs on top of AWS. So just to kind of mention that too. Yeah.
Right.
Yeah, absolutely. And that really touches on a real strength of Arduino that Pro enjoys as well, which is the exposure to the thousands of libraries that have been written for Arduino devices in the past, that many users have already used in the Maker and EDU worlds. You know, I2C, Bluetooth, Wi-Fi, all of these types of libraries are, you know, open source, well tested, and ready to be used on all of these different platforms. What's really nice about Arduino, again, is that middleware layer that we offer that allows us to span all the different silicon vendors, right? So we have the devices that power many of our PLC devices are ST. We have Renesas, a lot of different silicon vendors that Arduino's middleware allows you to have access to and sort of move in between. So it's really powerful from the tool chain really adds a lot of value and simplifies customers' development time.
Yeah, I want to ask you, I'm going to slide down here. I think there's some information. I was wondering if you could walk us through the Opta feature set, and I'm just going to use this to supplement for a moment. And I think you have something to show us.
Yeah, absolutely. So I might have buried the lead here, but yeah, so this is a really clear sort of feature description of all of what the base Opta has to offer. So like I said, it's a micro PLC that you can program with either C++ or a PLC IDE. The second one we'll show you. The first one many people are already familiar with. It's a part of the Arduino ecosystem. So again, you can bring in libraries or you can build on top of what other users have already done to, again, accelerate your development timeline. Obviously, there's opportunities for real-time control with this, right? So the microcontroller is a very high-end MCU that you can cycle through C++ code very quickly. Or in the PLC IDE environment, there are task prioritization. So you can run things at a 10 millisecond task update interval and keep those higher priority tasks working at a different clip than your others. So a lot of different ways to optimize and prioritize the way you execute code. We talked about software libraries. We talked about the IEC 61131 languages, so ladder, structured text, functional block, all of those languages are supported. Field bus integration. So we have either an Ethernet connection on device, as well as RS-485. Modbus TCP over the Ethernet connection is also available. You can implement, again, these either in the PLC IDE language or with C++ questions. So let's see, security, we definitely went in depth on that already. The ability to do OTA updates. So this is true for every Arduino Pro SOM-based solution because we have those security elements. And again, because provisioning, that ease of use with provisioning with Arduino Cloud, one of the other really killer features with Arduino Cloud is a very easy to use, easy to implement OTA function. So in many industrial applications, you want to be able to reprogram the device without what everyone calls the sneaker net, without having to walk out to the device and plug in a USB cable and reprogram it. Mm-hmm. So this is a really big feature of Arduino Cloud coupled with our hardware that makes it simple for almost anyone to do this. Altogether, what this really presents to the industrial automation space is a highly flexible micro PLC that enables companies and enterprises to continue this Industry 4.0 journey that every company is going on, but in a way that can help tackle the workforce shortage. Believe it or not, there's quite a few people. As software engineers continue to grow, hardware and controls engineers are flatlining in terms of growth. And having something like an Arduino that almost everyone knows how to use, that almost a pure software engineer himself could use, as well as being able to be the same device being able to be used by let's say old school controls engineer, really makes it easy for companies to standardize on a single hardware offering, but still enable use by a lot of different people.
I'm going to stop sharing this. That way you can show us what you got over there, Jesse.
Yeah, absolutely. One thing before we switch to the demo, one thing I did want to highlight here were the expansion modules here. So on the main Opta, there is a little expansion port here, and this is able to accept and essentially daisy chain up to 5 additional hardware modules that you can essentially extend I/O in a modular way. This is supported again in both tool chains, the PLC IDE and the Arduino C++ tool chain. We have 3 different flavors of expansions. There's 2 different digital expansions that add extra analog sensing, as well as solid state relays or electromechanical relays. And then on the other flavor, we have an analog expansion that adds 4 to 20 milliamp inputs, 4 to 20 milliamp outputs, and PWM outputs. So the Arduino Opta is transforming into a family of products that really make it easy to add to sort of build out your best use case for the right amount of money. Let's see. I have a question in the chat about edge control accessory. I'm not exactly sure what that means, edge control accessory. So, there's, in terms of being able to interact with other devices on your factory floor, basically the menu of options you have are RS-485, 232, all of the RS languages. There's an Ethernet port that can do Ethernet, MQTT, Modbus TCP. As far as interacting with sensors and other devices, there's 0 to 10 volt inputs. There's digital inputs from 0 to 24 volts. On the expansions, there's 0 to 10 volt inputs, 4 to 20 milliamp inputs. There's 4 to 20 milliamp outputs, PWM outputs, and I believe a PT100 thermocouple input as well. There are relay switch outputs, solid state relay outputs. So these devices don't necessarily provide power. They don't drive power. They could not drive a motor, but they could relay switch a power supply, which we'll show here in a second, to control like a high voltage, high amperage line. So I hope that.
So they're asking about the edge device accessory that was shown in the previous slide.
Let me pull that up.
We can bring that back up.
Give me a minute. I got it right here.
Absolutely. So the edge control, Arduino edge control is another device. We don't have it necessarily on display today, but the edge control is a carrier board. Well, it's a device suited for agricultural applications. So it has watermark sensor inputs, 0 relay switch outputs that are specifically designed for controlling pump relays and watermark sensor inputs, as well as a number of connectivity options for Wi-Fi, cellular, LoRa, that really address, again, the agricultural use cases of agricultural automation, let's say. So that's a small bit about the edge control. I recommend visiting the Mauser website or the Arduino website to find out more about the edge control.
And you could do that at mauser.com/Arduino if you want that URL.
That's right. That's right. So I think maybe to move the conversation on a little bit further, we could maybe talk a little bit about the use case that we all came here to discuss and sort of walk through this demo that we have here. If you'll allow me to switch my camera. I think everyone can see that.
And we'll make Jesse a little bigger here, so everybody can see.
All right. So what you're looking at is a very straightforward case of what I would call a pretty fundamental industrial automation use case. In my vision, industrial automation oftentimes is about 3 large building blocks. One of them is sensing. Another one is computation and communication. The third one is actuation. So we wanted to build something that that demonstrates what the Opta being able to do all of those. So what you're looking at is a simple moving water demo that uses basically a pump and a valve controlled by the Arduino Opta's relay switch outputs. You have an HMI here that is talking to the Opta via Modbus TCP. Up here we have an Opta expansion, just to sort of demonstrate the ability to do control on either, as well as a power supply that's driving a lot of this. On this side, what you're looking at are just simply 2 water tanks. And in the back of them, you can see water level sensors. These water level sensors are updating live data to this screen, again, via that Modbus TCP connection. So you can see when I start to let water go, you'll start to see the HMI reflect the moving water and the changing update solution. So when I move the water down here, data on my HMI is being updated. You can imagine this data being streamed to the cloud or another device or what have you. So right here, you can see the sensing. The sensing piece is already, the sensing and the connectivity, let's say, has sort of already been demonstrated. With the HMI, I can actually send commands to it as well. So if I ask it to pump, start to move water from the lower pump to the higher, from the lower reservoir to the higher reservoir. When the PLC or when the lower water level is detected to be 0, we can turn off the pump. So again, a very, very basic use case that's really powerful at the same time, demonstrating what the Opta is really suited for, where you know, there are thousands and thousands of use cases out there in the world where something at this price point is really makes a lot of sense for customers to do. Maybe spending $2,000 on the setup doesn't make a lot of sense, but doesn't justify a return on investment. But at $200, $150, you know, that's really changes the game and unlocks a number of use cases. So I'll pause there. Robbie, did I miss anything? I want to make this a conversation.
No, I think
I probably took all the good points there, but did I miss anything?
No, really good, really good. The only thing that I would like to add is that we do have, we do support all the 6.131-3 PLC languages without PLC. So this demo, it's programmed in instructor text. So I just want to throw that up because, to be honest, when we were trying to build this, we were thinking, oh, what do we do? Do we do ladder? Do we do structure? And then our developer, he actually said, well, I'm better suited to do this in a structured text. So that's how he do it. So just to show the flexibility that we support many languages, and then you can bring like an engineer, right? That doesn't have the experience of ladder, but he can do it in a structured text. So yeah, just to give you the highlight.
Really good point. Yeah. So you know, again, this use case could be built in either language, and all of these functions would be able to be delivered. What you can see here, my camera's not updating.
It's okay. Give it a second.
Yeah. That's the bummer. Let me try turning it on and off.
Yeah, that's part of live events. Sometimes things.
Yeah, part of live events.
So, Robbie, you started mentioning some of the programming language as well.
Yeah.
Well, Jesse's working. What programming languages work well with it?
Oh yeah. So I think we have two platforms or IDE. So we have the PLC IDE, which it actually support puncture block diagram, structure text ladder, ISD, and the other one that I just don't have it in my mind. But you can also do C++ on the actual PLC IDE, which is amazing because you can just copy and paste a C++ code and you just can paste it and actually send data to the cloud. So that's kind of like the main, but what the people really like is a structured text, ladder logic, and the C++ share variable. So those are the three main. The other ones are just the other people of the room. There would like the control engineer in the room that I have to actually have experience working with other functional block diagrams and other programming languages. But those are the three that actually are very suitable for Arduino products. And then the Arduino IDE, of course. Yeah.
Of course. Yeah. So, this is just a quick sneak peek of the PLC IDE. I won't go into too much depth, but one thing I really wanted to highlight. So we've got one of our structured text programs here. And one of the most valuable things in an IDE, right, is the ability to do debug. So you can see those green boxes in the middle, the lower and upper tank. When I start to send data out of those, there we go. We've got updating values, right? So you're able to actually see live data as I move water. Those water values are actually not only being reflected on the HMI, but in your IDE as well. So this is, exactly what developers need when they are developing projects in any language, right? But that is to say, the PLC IDE is basically, feature parity with a lot of the sort of industry standard IDEs that are out there on the PLC side. So just wanted to highlight that.
Yeah, and you were pointing on the actual program. Yeah, so you can. So this is what I did also, because I was working with that engineer, and then we also could create programs with ladder, structured text, and they will compile all of them. So you can create multiple languages and then also use the PLC IDE, which is great, because right now your calibration procedure it's working, but then you can control the light with the ladder. So you can just throw a coil and a contact and just create like a output for. So it's just really, really simple to use, and for me, a game changer.
Yeah. Looking in the chat, I see a question from Tomas about the EMR outputs. I don't have the data sheets right in front of me, but I believe that the EMR outputs of the expansion modules have a lower max current output. I believe it's 2 amps, where the EMR relay switch outputs of the base Opta have, I believe it's 4 or 5 amp max output. But that's essentially the main difference that I know between the two EMR versions of the Opta and the Opta expansion. Also, there is another solid state. There's a digital expansion version that has solid state, that has silent switching, as well as the ability to do many thousands more times of the on and off motion. So that's the sort of high level difference between that. I
think the main Opta has 4 relays with 10 amps. They have a AC circuits 250 volt. If you go to the EMR, which is an electromechanical relay, you have 6 amps, 8 6-amp relay on the expansion model, and then you have the solid state relay with a 2 amps. So you have 8. So you have, if you put 3 of them together, you have 4, 8, and 8. So it's just going to be like 16, 20 actual relays between AC and DC. So it's just a game changer. Well, and then the AC for the AEMR, but very powerful.
And just to clarify for the audience, the question was around the differences between the outputs of the Opta Micro PLC and the EMR outputs of the expansion module. So Tomas wanted to know if the EMR outputs had better electrical performance compared to the Opta relay outputs.
No, it's a really good question, and it's the price point too, right? So the solid state, of course, will have fast switching, and then if you have the EMR, it's just an electromechanical relay. I just want to say that we do have a good MTBF on cycles for the electromechanical relay, and we actually that's why we chose Finder, right, as our partner. So it's a really reliable electromechanical switch. But also, then if you prefer the solid state drive, then you can just go into the other expansion. So you have the option, and it's depending on what you need to use and the price point that you want to spend.
Right. So now you mentioned price point. So what does the Opta cost? What's the right?
Yeah, great question. So there are basically 3 flavors of the Opta base model, the non-expansion versions. There's a And that basically describes the amount of connectivity that's available on them. So the Opta Wi-Fi, it's around $200, between $195 and $200, available on the Mouser website. That includes everything. So it includes Bluetooth, Wi-Fi, RS-485, as well as Ethernet. Taking one step down into the 175 range, there's a RS-485 version that has everything except the wireless, the Bluetooth and the Wi-Fi. And then if you get rid of, and then the lowest rung is, or let's say the most cost-effective rung is the Opta Lite, which only has Ethernet, no RS-480, no field bus, and no Bluetooth Wi-Fi, and that's around $150 for one.
We have another question from the audience. Are there plans to expand communication capabilities, for example, Ethernet IP?
I think it's coming. Ethernet IP is one of our desired protocols that we would like to support. We do have the driver, but we don't have the library, and that's the gap that we are going to fulfill. So Arduino, it's coming with different, but we are expanding, right? And our communication will be handling in that way. We also are looking into other ways of communicating integrating with Ignition, and then also integrating with other platforms. So we already know Ethernet IP is a must, and then we're gonna work on that and help you guys to get those libraries available. Jesse.
Absolutely.
You're smiling for
correct answer. I think the official answer is stay tuned. We should have more to say on that topic.
Yeah. So here's a question. Do you need the Opta base model to use the expansion?
Really good question. And the answer is yes. So essentially the Opta base model is the one that has the full microcontroller on it that is needed to drive all of the others. The expansion modules do have some smarts in them, but they don't have like full programmability. They essentially sort of just pass on the signals that come in through here. So the short and simple answer is yes, you need to start with the base model. I would recommend starting with the base model, trying to address your use case, and as you need more IO, simply just sort of adding that, adding on as you go. Okay.
Now, what type of HMIs does it work with?
I can take that one. Robbie, do you want to take it?
I mean, yeah, you can take it. I know it's
sure.
It seems like both of you have an answer for this one.
Yeah, absolutely.
We do have an answer, and we have different. But no, since you are with the demo, then I believe you can maybe point to the HMI. But anyway, go ahead.
Absolutely. So the HMI that we're using today is a Wintec HMI, and we've worked with them on a number of use cases. What's really powerful about that one is there's a YouTube video already online showing you how to actually integrate those devices. You can check it. You can YouTube search that if you'd like. Plenty of enablement on that. But what makes Arduino Opta really powerful is, it's definitely not a closed ecosystem. What's required to talk to the HMI today essentially is a Modbus TCP library. So any HMI that can speak Modbus TCP or any other of the communication standards that we covered here, right? It could be an Ethernet connection. You would be able to implement an interface. So right now we're just sending Modbus TCP registers, which is a industry standard communication protocol. We're loading specific registers, and the Wintec is reading and writing to those registers, right? Because we have dual communication with the HMI here. We're able to send that pump command as well as send sensor data from the Opta to it. So it's really up to your imagination in terms of finding the right communication protocol, implementing it in either the PLC IDE or the C++, and you're off to the races. So it's really about, again, understanding which standard is used and then mapping the Arduino version of that to the HMI.
So you mentioned the pump demo, right? So does it have enough power to control a motor, or do you need a motor driver, right? So what's the power output, Robbie?
Yeah. So on this particular question is like we have the only way that I believe that we can do this if you want to bring a motor is using the PWM on the analog expansion model. But I don't think we have enough power to drive a motor. But we play very well with motor drivers. So we do have a lot of customers that actually come to us to use this as a control, control signal device. So that's the way that we can actually complement with the industry of the motion control, right? Now we do have ways on with the actual Opta or the Opta expansion models to EV on the pad of the motor by using a DC power supply if you want to use a DC motor. So you can actually close the relay and then kind of like power the circuit.
Okay.
So those are there are multiple ways that in architecture that you actually can build your motor control, but directly we don't have the FD, the variable frequency drive because we can't control frequency or voltage, but we are really good on controlling control signals that are going to be on those motor control. Yeah.
We have another audience question here from Larry. Larry wants to know how much flash and RAM the Opta has, and also if it's expandable.
We do have a 2 megabyte internal and 60 megabyte flash memory QSPI. It's not expandable on the device. It can be partitioned, so you can actually split in different parts of the memory. And then also we have a 1 megabyte RAM. So if you want to addition, what we are recommending is either you can have the possibility of adding a extra Arduino board that actually can get an SD card. But I will say that you first try the flash memory because you may find that that's the only thing that you need, and that's what the customers are coming like. Oh, I need a SD card. No, you don't. You maybe need to test and see what's the data is coming, and maybe that's enough for you. So just kind of a recommendation, but it depends of your use case or how much data you're storing.
Yeah, absolutely. I would say for the majority of use cases, 16 megabyte onboard flash is typically enough to buffer the data. You're usually not using it as an offline data logger, right? So the data, it's typically a buffer, and then you're either taking it to another device via communication protocol or to the cloud. So that was, again, because this isn't able to do that, this can be used as a device to, again, store the data. If you go offline for a couple of hours, maybe save couple of hours of data or a couple of days of data, and then once you regain connection, sort of getting into the cloud or off device.
So are other Pro products compatible with other third-party systems or software? And if so, what kind of integrations are supported?
Yeah, I think we are working right now with, we have platforms and software that we can use, Python and Java. Arduino CLI, Arduino Cloud CLI are the main ones. And the reason why we bring that up, because we have an API for our cloud. So once you provision your device in the cloud, then you will need a way to integrate or doing. So then you can use Python, and that's how we actually bring into the table a language that you can work in your cloud application or use to front end or other application that you want. Microservices in general. So Python, Java, and I'll say that Shell is also a program or software platform that you can use Shell with the terminal. Yeah. Anything else that you wanted to add there, Jesse? Arduino ID.
Yeah, there are, I would say in terms of integrating with other devices, we've mentioned the cloud story already. It has the onboard hardware to do that. And then, essentially, so the field bus is a pretty well-defined standard as well as far as integrating to other, let's say, IP-based devices. It really comes down to whether a library has been written for it. So the ones we've said, Modbus TCP, MQTT, web fetching, Those are obviously available. There are some like Ethernet IP, OPC UA that are sort of on our radar. We understand they're sort of table stakes to play in the IA space, and they're things we are definitely looking at. It's really comes down to at what level, and I think I believe that the hardware on here supports a lot of those different integrations. It comes down to software, and I guess we'd have to sort of dive into specifically which integrations are important and valuable. But right now we support a large number of them.
Yeah,
and there's been quite a few questions on that actually in here.
Yeah. And I would say, like, and the reason why we are very open on that question, and it's like a very broad, because sometimes customer come, hey, I have an application that is integrated on Ignition, and we didn't know that we couldn't have done that, but it's just the flexibility of the product, and it's versatile, right? Like you can really create your own integration in that sense and integrate it with the platform if this mod communication or the protocol is supported.
All right, so we have some more audience questions. I just want to get to some of those. We have another question from the audience. What is the detection method by which the Opta Finder inputs Finder or Finder? I know you work with Finder. Is it Finder or Finder?
I believe it's Finder. Yeah.
It's Finder. Yeah. Okay, I didn't know if it was the word Finder. Finder inputs can differentiate between PMP or MPN signals. Do they have a specific detection circuit?
We have a circuit that we have a specific circuitry that we support, and yes, we have for example, on the expansion model, we have a way to detect the expansion model, and it's going to adapt into the architecture, and we'll be able to detect if it's either NP. Sorry, the question when answered, I didn't see if it's either PMP or
NPN.
Or
yeah.
Sorry.
Yep. That's okay. We also have another question. How well does the Opta handle shock and vibration? Stephen asks. I'm thinking about mobile applications. So that's a good question.
It's a very interesting question. I would need to honestly see if circle back with our teams to understand what kind of actual serious vibration testing has been done. I can say that we have a number of customers using our device, using the Opta on mobile applications. I can't confirm whether it's on a paint shaker or something like that. I'd have to understand the specifics around how much shock and vibration. The Opta is IP20 rated and designed for industrial use cases, but I don't have a lot of clarity on the sort of industry grade vibration at this time.
Yeah.
So Stephen, if you have an idea of what you want to do with this, we'll definitely hook you up with Jesse and Robbie at some point, so you guys can. That would
be fantastic. But I just think for him, I just think on the app, the Opta as a very good device to be on your electrical panel and the vibration that comes with it. So it's an IP20, it's an IP20 rated device. So yeah.
We can keep going through. I love the questions, guys. We can keep working through those.
And they keep popping in. There's a lot of questions going on.
Go ahead, Brian.
Well, here's another question about sort of does the Opta have robust pin I/O protection? So
yes, we do. We do have. We have a I/O protection. Since it's supported it comes with the STM. But yeah, we do have a overcurrent protection and all the good stuff on the actual Opta, that it actually reversing voltage protection. So there is a diode there. Actually, we can definitely circle back with you. But yeah, there is a huge amount of effort that our team put in to get the best value on those particular circuits, because we know that they're very high power usage. So,
those input over voltage protection and anti-polarity protection are noted on our data sheet. So I'd recommend checking that out.
All right, let's see. Is there a case where the Opta can be accessed remotely to apply updates and other administrative tasks?
We have OTA.
Yes. So OTA would be the method for doing that. So Again, you can provision these devices on Arduino Cloud. You can actually, there's also tutorials available on our website for implementing this locally. So if, say your Opta was on a closed circuit, air-gapped LAN network that was not connected to the network, there are customers that are able to push OTA updates from a PC locally to this device and be able to update it as well. For a more seamless, easy to use version, you would simply work with our cloud. Like I said, provision this device in about 5 minutes online, and then you're able to push sketches, which what we call our programs, to the device from the cloud. So yes, that use case is supported today by the Opta.
Yes.
Okay. So we have another question. Is CAN bus J1939 planned?
JBus
Really?
can. Yeah. It's we don't have it right now, but yeah, J1939 is something yeah, we wanted to play with that. It's pretty much automotive. So we do wanted to play with automotive, but for now it has to be, I think we don't have it in Octa, but we have it on the Portenta machine control, which is here. Yeah, we both show it, which is amazing.
Great, great lead. Yeah, so the Opta currently doesn't have plans to support CAN bus right now, but the Arduino SOMs do have support for them, as well as this is Arduino, what we call a soft PLC, because it doesn't have any ability to do like high amperage, high current, like our relay switch outputs, but it's also powered by the same microcontroller underneath. It includes a lot of digital I/O, encoder inputs, Wi-Fi, Bluetooth, I2C, Ethernet, USB host, CAN bus, 24 volt power rails, CAN bus, RS485, J-type, K-type thermocouples, and 4 to 20 milliamp and 0 to 10 volt analog outputs over here, and inputs, excuse me. So this is a really powerful, this can also sit inside of a cabinet and do IA related tasks. We have lots of customers that are OEMing their own solution who don't want to design their own circuits. And instead of building their own circuit board, they're using something like this if an Opta doesn't have enough IO. So there are options in the Arduino portfolio for CAN, but on the Opta side, we don't support it today.
So how scalable are the Opta and IO expansion modules? Can it be easily expanded to accommodate growing needs? Right? Yeah, really good question.
Try to stack it in each other. Try to stack it in each other, Jesse.
Exactly. So adding an expansion module is about as simple as this. So they just
click them together.
Daisy chainable. Yeah, exactly. Daisy chainable up to 5 additional expansion modules. So you can mix and match whichever IO that you need. And this makes it really cost effective and modular, and allows you to, again, standardize on Opta as very cost effectively, where you can really pinpoint the number of your IO count for each use case that you're doing, and not have to overspend or standardize on something massive just to solve that 1% case. So the flexibility is really is awesome, and the libraries on the C++ side already exist for all the expansions, and on the PLC IDE side, it's already integrated. So as soon as you plug it in and plug in your tool chain, the IOs, the software takes care of the rest, and you should be able to start seeing data pulled like almost instantly. So it's really seamless and very painless to sort of bolt on additional IO in that fashion.
So what makes the Opta different from a relay board?
Yeah, I mean, based on my experience that I work in the field before, it's just that the Opta has we have the control, we have the board that has the secure element, that has the processing capability. it actually brings this life to the relay board. So if you have a relay board, you're just always expecting to have a connection or integration with a microcontroller. We already have it in one device. So, and that's kind of like the beauty of the Opta bringing to life with control capability. But I believe that the connectivity aspect is something that everybody's impressed, because we have the capability to do the Ethernet, Wi-Fi, and the BLE. So it just bring the connectivity, bring the processing capability, and make your relays actually to be smarter in that sense for your IoT IoT devices. Yeah.
Right.
Anything else to add there, Jesse? Go ahead.
Jesse.
Yeah, I mean, what I would say is, we see this, the birth of the advent of the relay board has come about because customers or folks in enterprise were trying to create custom PLC boards. They started in the PLCs, either too expensive or they needed to create their own custom solution, and the democratization of, let's say, electronics and the easier way to spin out boards made it easier to do, let's say, a custom design on the relay board. I would say many of the Arduino customers that have moved to the Opta have come from their own custom design, and it's because they've come across a lot of pitfalls in designing their own PLCs, their own relay boards, because they forget to design in connectivity, or they forget to get UL or FC certified. That's a really important part of having working equipment on the factory floor, those certifications. The relay switches from Fender, having the name brand of those relay switches, those mechanical pieces, the things that are actually moving on your factory line, are really important to have high quality, so you get that in mean time to failure number that Robbie was talking about. You want to have a device that you can trust, that you don't have to replace constantly. So a lot of customers that we have today are coming from that custom relay board. I tried it once myself. I made 500 of them, and now I am stuck with maintaining my own schematics and supply chain and so on and so forth. So a finished product that costs $150 to $200, I think, is really, really attractive, and a great option to be considered by that audience.
So there's a question here. You mentioned approvals, right? What approvals does the Opta and the expansion modules have?
I'm not sure I understand the question. Approvals.
I guess
I
maybe
mentioned the
rating,
FC and the UL, the certifications, the FC and UL certifications, ENEC, and then the IP20 rating are really the ones that I can point to right now. Our data sheet can sort of elucidate sort of all of the other approvals or certifications that it has.
Yeah, FCC is also important to mention too. FCC, we have IC, CE, so those are really the most important one. And yeah, I mean, and then we have a declaration of conformity, ROSH, the REACH, DOC for the UA. So it's just a variety of compliance. Yeah, those are all on the collective data sheet that we have for the Opta, and you can actually see if that's compatible for the region and the area that you're working on.
Okay, they gave some clarification. UL approval is what was meant. Yeah. Okay. So there you go. They asked for a few others.
UL.
Oh, the UL. Okay. Yeah.
CUL, CRUS, and CSA. So,
yeah. With the UL, it's a little tricky because you don't really need to have that certification, but it's required in a lot of cabinets, and especially with electrical. But we are. Yeah.
Okay. Awesome.
So is there an Opta AI Edge extension plan for the near future? We have a participant asking.
I like this question.
This is a fantastic question. So the best part of this answer is that the Opta itself isn't able to do AI, and that's because, again, the Arduino lineage of coming from the microcontroller SOM space, we have a dual core device. It has a STM32H747, has a Cortex M7 and an M4 inside of it. So there's two cores in the device. Both of these are capable of running C++ code at the same time, or you could run ladder logic, PLC IDE, the ladder logic code, your industrial automation use case on the main core, and then program the M4 core with C++, where you could implement a anomaly detection, any kind of ML, let's say lightweight ML application that you can implement in C++. You absolutely can do that, and we have a lot of use cases where customers are using the split core functionality to implement an AI or ML workload on one of the cores, and then doing that, and then actuating, sensing, communicating everything. You're running your main program on the M7 core, so it's very straightforward to do through our IDE. The C++ IDE, you can select the core to program. They can share data between each other, and then in the PLC IDE, actually, to the right of the structured text or whatever program you have, there's an extra window where you can write the C++ program as well. So in general, there's no extra hardware needed to implement AI or ML. It's more about sort of carefully constructing and obviously managing the resources on the Opta to make sure you're running as efficiently as possible. But yes, it's absolutely possible to do AI and ML with the base level Opta only.
All right, guys, so we are approaching the top of the hour. We have about 4 minutes left. So I wanted to see, do you guys have anything else that wasn't asked today that you think should have been asked that you'd like to address before we wrap things up for the audience?
Yeah. I really think we covered all of the big talking points. I see a really good one last follow-up question here in the chat about offering any in-person hands-on training courses. I would say the hands-on might be a little, let's say, resource constrained on our side, but what I can share, and it's actually on one of the slides that we were sharing before, the Opta we are getting ready to launch an Opta PLC training course for folks that are learning, wishing to get involved with. I think if you go to maybe I think it's at the top of the portfolio with the one with the cloud on it as well. There, down one. I think down one. Right. Yes, right here. So in the middle there, in the bottom, we actually have for sale a couple of trainer kits that basically simulate I/O connections, relay switch outputs, and just turn on lights and such. This will be what's included with this. There's essentially a free online course that you can register for that leverages all of this hardware. You essentially just need to buy the hardware, and the software course comes for free. Includes like badging, so you can add to your LinkedIn profile. Like I got this certification from Arduino for PLC.
Cool.
So I would recommend that as a self-help avenue for coming up to speed with the Arduino PLC.
So, Robbie, did you have anything did you want to close out with anything?
No, I think we have covered a lot of information, and I'm happy I'm happy that everybody has a lot of questions too. So yeah. All that I have to say. Yeah.
Awesome. Yeah. Well, thank you for joining us today for this live chat. Thank you to our sponsors, Mouser Electronics and Arduino, and our amazing panelists. For more, visit mouser.com/Arduino. Have a great day, everyone.
Thank you.
Bye, guys.
Have a good day. Bye. Bye.